Hey everyone, this is Mr. Ferentz, and today we're going to be talking about motion graphs. These are a really important thing for us to understand because it's a way for physicists to describe how something is moving and to pack a whole lot of information in there without having to use paragraphs of words and descriptions. And so to start off, I want you to imagine that I have a motion detector set up where my camera is. And once I hit record, it's going to just measure where my distance is in relation to it. So I can be further away, I can be close, and it's going to display it on this graph. Now, the axes we have set up here is we have time on the horizontal axis. So as time goes on, as we're recording, we're going to see this graph fill in from left to right. And on the y-axis, it's measuring the distance from me or the object or whatever to the recorder. So the origin would be right where the recorder is. And the further away we get, that's going to be a positive y coordinate. So what we would expect to see if I start kind of close, if I start kind of close and I move further away, the graph we would expect to see is going to look something like this, right? I'm starting fairly close, so it's a small y coordinate. As I'm moving further away, as time progresses, I'm going to have a much higher y coordinate. Now, think about another situation where I hit record and I'm here and I just stay here the entire time. My graph is going to look something like this. The entire time it's recording, my distance is not changing. I'm not moving further away. I'm not moving closer. I'm just staying in the same place. And we see this horizontal line on the graph. So when you see something like this on a distance time graph, this flat horizontal line, that means the object or the person is standing still. Now, if I'm starting further away and maybe I'm moving a lot closer, we would see something like this, where again, I'm starting at a higher distance, at a greater distance, and my distance is decreasing as time goes on. So these motion graphs will tell us whether, what direction we're moving, whether we're moving, we might just be stationary, standing still. Another thing that it can tell us is, well, imagine this. Okay, so imagine I start close and I start moving further away. Now, let's say I did this again. I start at the same point and I move further away, but this time I do it a lot faster. The graph is going to look something like this. So on the left, that was the second time. On the right, that's the first time. Now, at both of these points, I'm starting and ending at the same distance. But the difference is, the second time around, this graph on the left, I got to that distance in less time. It took me more time to go the first time. And getting there in less time, in physics, we call that going faster. So the other information that we can get out of this is that a faster object, person, car, whatever, we're going to see a steeper graph. A slower object will have a much shallower graph. So what if we start to speed up? What if I start out kind of slow and I get faster? If a slower motion has a shallower graph, what that means is we're going to have sort of shallow at the beginning, and then the graph is going to get steeper and steeper as time goes by. So it's going to look something like this, right? We start out kind of slow with a shallow graph. We get faster and faster and faster, and it's increasing that slope. So if you look at a graph like this, if you know how to pull out the information, it's going to tell you that we're speeding up. If we're slowing down, we're going to see the reverse. We're going to have a very steep graph because we're going fast, and then that is going to get shallower and shallower and shallower. So it's going to look something more like this. Again, if you see a shape like this, that means we're slowing down. So these motion graphs are really useful because if you know how to read them, and it'll take some practice, but you will get there once you know how to read them, You can find out whether something is moving, which direction it's moving in, how fast or how slow it's moving, whether it's moving at a constant speed the whole time, whether it's speeding up or slowing down. There's also some information that if we dig a little bit deeper, we can get some really, really cool info from the slope of the graph. Okay, now flashback to math class where we have a line. We have 2 points on the line. Doesn't matter where the points are, but it's just any 2 points on the line. Let's call them point 1 and point 2. Point 1 is at the x and y coordinates x1 and y1. Point 2 is at the coordinates x2 and y2. And the equation in math class that we use for figuring out the slope of this line is this, that y2 minus y1 over x2 minus x1. So let's say that we did all of that. Okay, so we figured out the coordinates of those points, we plugged them into the formula, and we got a number for the slope. Okay, the slope is 3, or the slope is 1.2, or whatever. So what? Who cares? Here's what's important about this. Slope is rise over run, which is the y-axis over the x-axis. But look at what we're measuring here. The y-axis is distance. The x-axis is time. So for this motion graph, what this is saying is that it's telling us distance divided by time. Now in physics, we also have a word, a sort of technical word that we use for distance divided by time. We call it speed. So the slope actually tells us the number of how fast we're going. So if that's 1.2, okay, that's 1.2 meters per second. It's 3 meters per second. That tells us, right, our speed, our velocity, how fast we're actually going. Really, really valuable information if you know how to get it out of that graph, which is what you're going to be practicing over the next couple of days. Now, your goal as a physics student is to be able to look at a graph. If I just give you a graph, you need to be able to give me a description in words of what is actually happening in that motion. You will also be working to using a description, starting with some sentences, a paragraph or so, to create a graph based on that description. It's going to take some practice, but you're going to get there. The next time we talk, we will look at some more kinds of motion graphs, not just position time graphs, distance time graphs, but also velocity time graphs, acceleration time graphs, and how there's also some information in there that we're going to be able to unlock. So good luck, and I will talk to you soon. In the meantime, take care of yourself.